Lines and slope on the coordinate plane. So yesterday we talked about the coordinate plane or the Cartesian coordinate system. And you probably remember that it's basically two number lines combined together. And we call this number line our x-axis. It keeps track of the values of a variable called x. And then we call this long down vertical axis the y-axis. And it is also a set of positive and negative numbers. And any point on this coordinate plane has a set of coordinates. So for example, the coordinates of this point right here, we always list coordinates in parentheses, and we list the x first and then the y. So this would be the x coordinate is 3, comma, the y coordinate is 1. So these are the coordinates of that point. Right? We could have another point over here, and it looks to me like the x coordinate of that point is -3, and the y coordinate is -5. So every single point on this coordinate plane, or we're now going to start calling this a graph, every single point on this graph has a unique set of coordinates. Each point is different. And what we can do is we can start to now connect points to form lines or line segments. In this case, if I connect these 2 points, I have what's called a line segment. Why is it a line segment? Because it has an end point and another end point. It doesn't go on forever. So let's say I had a whole bunch of lines or line segments on this graph. Right? Maybe I have some that go this way. What makes them different? What makes these lines different from each other, or these line segments? Well, like, what makes this one different from this one? Okay, it's in a different location. What's another thing that makes these different line segments different? That would help us to kind of identify them.
Well, some of them are diagonal, and some of them are straight.
So some of them are like almost straight up and down. Some of them are more diagonal. Some of them are almost straight across. Exactly. Yeah. And those two things are basically the way that we identify lines. Their position, and then that second thing, that's called the slope of the line. So the slope of a line is the steepness of that line. And it can be represented numerically. So instead of just saying this line looks really steep and this line looks not very steep, in math we can actually say the number of the steepness of that line. And we call that number the slope. So each line is going to have its own slope. It's possible for two lines to have the same slope. Right? For example, this line and this line have the same slope. They're both straight up and down. But there's also an infinite possibility of slopes that we could have. So let's start out with a line that looks pretty much diagonal. And let's say this line goes through the point 1, 1. And then it also goes through the point 2, 2. And if we made a line that went through those points, would you kind of agree with me that that looks diagonal, right? To be specific, it looks pretty much like 45 degrees on the graph. So how could we define the slope of that line? Well, there's a couple of ways. We can talk about positive and negative slope, and then we can also talk about the change or the rise over the run. So the change in y, or the change in x, is called the rise over the run. So if we look at this line that goes through 1, 1 and 2, 2. To find the slope of this, we say if I'm starting at 1, 1, my slope equals the rise divided by the run. So how much do I have to rise from 1, 1 to get up to 2, 2? The rise means how much do I have to go up or down? I have to go up from here 1 unit up. So my rise is 1. The run refers to how far to the right do I have to go to get to that point. So from this point, I go up 1 over 1. So my run is 1. So the slope is a fraction, but a lot of times it's a fraction that can be simplified. For example, we know that the slope of 1 over 1 is just equal to the number 1. So the slope of this line equals 1. So that perfect 45-degree angle slope is the same thing as a slope of 1. Which in a way kind of makes sense. It's like that 45 degrees is sort of like a perfect diagonal. Right? If we made it any steeper, we might start to call it steep. If we made it any shallower, we might start to call it kind of shallow. But it's right in the middle. 45 degrees is right in the middle. And that slope of right in the middle is a slope of 1. Let's look at some other lines. Let's say I had a line on my graph, and it went through the point 2, 1, and then it went to the point 3, 3. So my line that's connecting those 2 points. How am I going to find the slope? Well, the slope is the rise over the run. So I'm going to start at this point that's further to the left. And I'm going to figure out how much do I have to rise and how much do I have to run to get to the next point. So if I'm starting here, I have to go up 2 and over 1 to get to that next point. Do you guys see that? Starting here, I go up 2 over 1. And I end up at that next point. So my slope is equal to a rise of 2 over a run of 1. And 2 over 1 is the same thing as the number 2. So the slope of this line, which is a little bit steeper than this line, is 2. So a steeper slope is going to give us a larger number for our slope. Right? If I had a line that sloped from, let's start it at 1, 1, and then maybe it goes up 1, 2, 3, 4, 5, 6. Goes up to 6. Wrong way. Remember, the x-coordinate's always first. 3, 6. You see that this is now a very steep line. So what would we expect about the slope? Do we expect a large number or a small number or 1? A steep slope is going to give us a large number. Let's figure out what it is. How much do I have to rise and run to get to this next point? Starting at 1, to rise 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5, 6. I think I mislabeled it. It's actually 3, 7.
Okay, then you rise 6.
Then I rise 6, yeah. So my rise is 6. And how much do I run? If I go up 6, now I have to go over 1, 2. So the slope of this line is 6 over 2 or 3. Right? 6 over 2 is the same thing as 6 divided by 2, which is 3. So to find the slope, I'm starting at one point. I'm counting how much I rise and how much I run to get to the next point. And this slope is telling me something about the steepness of the line. So what if I have a really shallow line? Let's take a look at what the slope looks like then. Let's say I have a line. Slope is rise over run. Let's say I have a line, and maybe it starts right here. What point is that? 0, 0, 0. And maybe it goes over here to the point 5, 2. Would you agree with me that that line is shallow? Has like a shallow slope. If I were walking up this hill, right, I'd be pretty happy. Right? I could walk up that pretty easily. So how do we find the slope? Well, I start at the point 0, 0. My slope is rise over run. So how much do I rise to get to 5, 2? I have to go up 2. 1, 2. And then how many do I have to go over? 1, 2, 3, 4, 5. So run 5. So my slope is 2/5. That's a fraction, and I can't change that fraction in any way. It's simplified. Is 2/5 bigger or smaller than 1? Smaller, right? It's less than 1. And that's going to be true about all of our shallow sloped lines. The shallower the slope is, the smaller number I'm going to get. Right? 2/5, I believe, is 0.4 as a decimal. But we're typically going to write our slopes as fractions, not decimals. Even though the decimal might give us a somewhat better idea of if it's closer to 0 or 1. But we can see that that's a small number. So this is what I would call a shallow slope, and I would expect to have a small fraction, right, as my slope of that line. And then there's one other thing that can happen with the slope. So we can have a slope of 1, we can have a shallow slope, we can have a steep slope, we can also have a negative slope. So, for example, let's say I had a line and one of the points was at 1, 3. And maybe another point is at 1, 2, 3, 4, 5. Yeah. I'm gonna have to use the ruler to get that straight. What's the slope of that line? Well, here's the key. With slope, you always start at the point that's farther left. So I'm always going to start at this point, the point that's further to the left on the graph. And then there's something a little weird about this. I said slope is rise over run, but do I rise to get from this point to this point? No. I actually go down. I fall in a way. So if I'm going down, how many do I have to go down to get there? I have to go down 1, 2. So instead of saying that my rise is 2, I'm going to say that my rise is negative. So I didn't go 2, I went down 2. I went negative 2. And then my run is just always going to be a positive number because I'm always going to go to the right. So how much do I have to run? 1, 2, 3, 4. So my slope is negative 2 over 4, or that's the same thing as negative 1 over 2, negative a half. So the slope of this line is sort of gradual, and it's negative. What's the difference? Like, can you look at this line and tell that it has a positive slope, and then look at this line and tell that it has a negative slope? Do you have any guesses about what makes the slope negative? Yeah.
Because you're going down. So kind of like you're going down as the number line.
Okay. So from left to right, we're going down. So with this line, I have a positive or a negative slope. This line here.
Negative.
Negative. Because as I move from left to right, I'm going down. What about this line right here? With this line here, have a positive or a negative slope?
Positive.
Positive. Because as I move from left to right, I'm going up. Right? So all slopes have a sign. They're either positive or negative. And then they have a value, right? They have that rise over run. It could be a fraction. It could be an integer. But they all have a sign and a number. So you're always looking for that when you're finding this slope. There's also a couple other things that are sort of special cases of slope. The first one is this. What if I had a line starting right here? This point is 1, 1. And let's say it went over to this point. 1, 2, 3, 4, 5, 1. How would you describe the slope of that line? Straight, but well, I would say that this line is also straight.
But there's not really a slope.
Yeah, there's not really a slope. What would you call that if you're climbing a mountain that's not sloped? Flat. Yeah, I would say this line has a flat slope. So let's find out what the number of it is.
Could it just be 5? Yeah. Just
So let's see. What's my rise? How much do I rise here? If I start here, if I rise 1, yeah, I rise 0. And how much do I run?
5.
Does it matter? 0 divided by any number is going to be 0. Technically, with this one, I could say that I run 1 or 2 or 3 or 4. But the slope is 0. So that kind of makes sense. A flat line has a slope of 0. A flat line has no slope. That kind of makes sense in a way, right? Because it's flat. If I were running across this, here I am, right? I'm not going downhill, I'm not going uphill, I'm just going straight, flat, 0. Does anyone want to guess what the other special kind of line is?
Going straight up and down.
Exactly. Yeah. So what if we had a line that went straight up and down? How would you describe the slope of this line? Just describe it, not using a number, but how would you describe the slope of that?
Up and down.
Upwards. Is it steep?
Flat.
Yeah, like imagine this guy on this line here, right? Yeah, you have to be Spider-Man to climb this mountain, right? What would be an example of a point on this line?
1 and 2. 1, 2.
1, 2?
Yeah.
Is that on the line?
No. 1, 2, 1.
2, 1. Okay. So 2, 1 would be a point on the line. What would be another point on this line? How about this one? What point is that?
2, 2.
2, 2. Okay. What's my rise here?
1.
1. What's my run?
0.
0. Uh-oh.
1 happening.
What's wrong with this?
It's 0. And 0.
Have you guys ever seen Gary's shirt? It says, friends don't let friends
Divide by 0.
divide by 0. We cannot divide by 0. 1 divided by 0, we call this in math undefined. We call that undefined. Now, some people might call this infinity. They'd be wrong, but they wouldn't be really wrong. That's alpha, sorry. Infinity. So, in a way, the slope of this line is kind of like infinity. It's like a really, really, really large slope. But because in math we can't divide by 0, we really have to call it undefined. When the line goes straight up and down, our slope is going to have to divide by 0 because there is no run. There is no right to left. And so our slope would be undefined. Alright, let's do a couple examples. And in these examples, I'm actually not going to give you the points. I want you to figure out what points would be on this line. This will be easier when it's on graph paper, not on the board. But let's try to find like 2 points that we think might be on this line.
I know the bottom one. Wait, I know the bottom one. 2.
Where? What's the point on this line?
Oh, 2.
2 what?
2.
What's the y coordinate? Isn't it 0?
0.
There's 2, 1 would have to go up 1, right?
2, 0. Okay.
Okay, what's another point on this line?
3, negative 3. Yeah. Negative 2.
Wait.
No.
Negative 3. I don't know if that really lines up very well. Okay, so that's not maybe a good one. What about negative 1? That doesn't really line up too well. What about this one? Doesn't this point kind of line up?
Wait, can I do
Sort of.
Yeah.
What's 1 theta?
Okay, so if you go to the left, so it would be -3. Yeah, here. Down, like at the point, -3.
Mm-hmm.
And did you add an extra one there?
No, sorry. I was just showing that we kind of tried -3 and it didn't really line up very well.
Oh, but couldn't you do like -3, 1? No, but then you could 3 half. You could do 2 and -2 and -3. Yeah.
Oh yeah, -2, -3. That seems like it lines up pretty well, doesn't it? Okay. So again, like I said, on graph paper this will work better. On this board, and also because I'm not using a ruler to draw my axes, this isn't lining up perfectly. But let's say on the graph paper we'll know that these are points because you'll see on the graph paper that actually is a corner, right? So it will actually be where the lines on the graph paper form a corner. Those are the points that you want to look for, because those are sort of perfect number points. So how do I get from -2, -3, up to 2, 0, this point right here? How many do I have to rise? 1, 2, 3. Is that it?
Yeah.
Okay. So 3 is my rise. And then how many do I have to run? 1, 2, 3, 4. So my slope is 3/4 based on those 2 points that I found. Okay, what if I had something like this? Here's my line. Let's say maybe it's like 1, 2, 3, maybe 4. What points do you think are on that line?
2 and 8, 2 and 3. No, you could do 1 and 2. Yeah.
1, 2.
Yeah.
Okay. We need a second point to find the slope, right? What's another one? Go for it.
1, 3. We do 1, 3. Yeah, 1, 3.
1, 3.
Yeah.
Is that on the line?
Wait, no.
Not really. Right?
0,
0, 3 is definitely on this line. Yeah. Okay. So then what's my slope based on these 2 points? 0, 3, and 1, 2. How much do I rise to get to the next point? -1. And how much do I run?
What would be 0? What? 1, 1, 2, 1, 1, 2, 2, 1, 2.
Let's think about it.
1.
So I'm here.
1, 2.
I go down 1. Am I at the point?
Yeah. 1 point. No.
No, I have to get here.
1.
I have to go over
2.
1, right?
Yeah. It's just 1, 1.
So -1 over 1, which is equal to -1. So I go down 1, and then I go over 1. Down 1 over 1 equals -1. So my slope on that line is -1, approximately. Again, the way I drew it, if you choose different points, you might get a different slope. On graph paper, that won't happen. All right. What about this line? What about this one?
It's 0.
Yeah, immediately you know the slope is 0. Because I'm going to rise 0, and it doesn't matter. I could say the point is here or here. So I go over 1, I go over 0 over 2, 0 over 3.
0.
The slope is no matter what, it's 0. Right? What about this line?
0. 0, 1.
Let's pick a point. So let's say I had,
So it would be 2.
so this would be 2, 0. And then what's going to be true of any other point on this line? Like, no matter where I go, what's x going to be here? What's the x coordinate here? The x is still 2, right?
Yeah.
And then the y would be -2. But then I could also have a point here, 2, -1. What's true of all these points?
Oh, 2.
The x coordinate is always 2.
So it just equals 2.
So the x coordinate is always 2. Okay, so let's just choose 2 points. Maybe this point and this point.
Okay, so
How much do I rise to get from here to here?
1.
1. How much do I run?
1.
Do I have to go over?
2.
So I rise 1. How much more do I need to move?
Oh, 2 more. So 1/2. You don't have to move it.
I don't, right? I don't run. I don't want to move to the left. I mean to the right.
So it's just 1.
So I run over 0.
So it's just 0.
1 over 0 is not 0.
Just 1.
What's wrong with 1 over 0? Friends, don't let friends divide by 0. This is not allowed. And in math, we call this undefined. Exactly.
So all the lines that are going straight up are undefined.
So the slope of a vertical line is undefined. No, just put undefined. You can put undef if you want. If you want to abbreviate this, just do undef. That's fine with me.
Can we start the homework? Yes,
Yeah.
please.
So now we're going to practice. Let's